Good evening, this fine evening, if you're with us here in Lagos, Nigeria. Like we promised, we like keeping to time and then starting off our programs like super early, right? So welcome to everyone who is joining us. We wouldn't be able to, take introductions as we want to like get straight into the meat of the matter where we are here. Having said that, I'm just going to quickly introduce myself. My name is Emmanuel Oahina, and these sessions are called Web3 Dev sessions, and they are dedicated specifically to peer learning for developers in the Web3 space with a very strict focus on sharing technical content. And having said that, I'm just going to hand it over to Mayowa, who will go ahead to introduce himself, and we can dive right into the session so that we can keep to time and spend the next 1 hour being productive. Welcome again, everyone. Thank you. Over to you, Mayowa.
Yeah, hi everyone. I'm happy to be here. My name is Mayowa. Okay, I'm a blockchain engineer. I'm also the founder of WalletCloud. So WalletCloud is a blockchain wallet infrastructure as a service provider. That's a mouthful, but just consider it to be paystack for this amount for blockchains. Right? So if you intend to integrate wallets into blockchain wallet into your application, and you need APIs to do that, you can use blockchain APIs to do it. Yeah. So I'm also a blockchain engineer. Yeah. Work with crypto infrastructure for keeping liquidity available on all the layers of Ethereum that we have right now. So between layer 1 and layer 2, we want to ensure that there's always liquidity. So, for example, if you want to transfer some funds from, say, Polygon to Arbitrum, right now there's no interoperability between both chains, right? So what we do is build infrastructure to facilitate that, so that you can send money from one protocol on one layer to protocol on another layer, or even on the same layer to be that system. So that's what I'm currently doing right now. Okay. So today we'll be talking about blockchain explorers. The title of this conversation is the technical panel on blockchain explorers. So blockchain explorers are like very, as an introduction, blockchain explorers are very common right today, and they are taken for granted a lot. But when you, as a developer, or even as just a another user, interact with them, and you understand the technical aspect of working on some of these things, you appreciate the work that blockchain explorers are doing, right? So this kicked off from one of those days I was just using the blockchain explorer, and I asked on the group, how many people are very familiar with explorers, and can use it confidently, and a few people indicated that they could not, and we had a conversation, and here we are today. So this is a more in-depth conversation on what explorers look like, right? So if you've ever used an explorer before, maybe blockchain.com, BlockCypher, Etherscan, name them, and if you ever wondered, how they work, what is behind them, so this is like an expose, right, into blockchain explorers. So who is Mayowa Tudonu? So like I said earlier on, I'm a blockchain engineer. I'm also the founder of WalletCloud. I've worked in this crypto space across like several sectors, fintech, crypto exchanges, DeFi, layer 2. I've worked on on a range of things. So previously I worked at InterSwitch, I worked at Bitcoins, I worked at Dex.ag, I worked at DeFi Pulse as well. So that's previous company. I'll tell you about where I currently work. And other fun things I like to do. I love old school music. I'm a huge fan of old school music. If you meet me outside and you want us like start a conversation, a very good way to start is just come up with an old school song, the title or an artist, and we'll just start talking. I love football, and finally, CR7 is good. Explorer. All right, so let's start with that. So Blockchain Explorer is what I generally refer to as a blockchain search engine, right? So just the way Google works, put in anything, it gives you information. Blockchain Explorers put in, I would say a finite set of queries, and you get, data. So some blockchain explorers are like, accept wildcards, put in anything, and they will try their best, to give information. That's how Google works, right? But in the case of blockchain explorers, some of them allow you to do that, right? But some of them don't. Some of them, just give you like a finite set of items that you can search for. Maybe transaction hash, wallet address, contract address, ENS, addresses. They provide that finite set of data, to query. And if your request does not conform to any of the data that you requested for, or they are trying to query on their platform, you get a 404, some nice message telling you there's nothing to be found. So that's essentially what blockchain explorers are. They are just Google. So that is like the way to explain it to a non-technical person, right, who is about to come into the crypto space or even in the crypto space. So what we're trying to do right now is simplify terms so that crypto terms don't seem too complicated for people to grasp. So if anybody asks what a blockchain explorer is, it's pretty simple. Blockchain search engine for blockchain networks. Right? So imagine Google for blockchains. That's what they are. Right? So my next slide. Why do we need blockchain explorers? If we are to justify these reasons, I like correctly I listed out some items here. So one of the reasons is blockchain explorers, they expose transaction transparency. So one of the key selling points of blockchain is transparency, right? So if I transfer money from person A to person B, it's going to be recorded and then duplicated across other nodes. So should different nodes fail, there will always be a node that will always have a backup of my transaction, right? And I cannot go ahead and change data that has been settled before, right? So you cannot mutation is impossible. You can't go back and change what has already been recorded on the blockchain, right? So, but the thing is, how do you tell someone that this is true? How do you show them that this is true? For example, bank transactions, the only proof we have that a bank transaction was successful is a receipt from your bank, right? Maybe on the other hand, from the recipient of the transaction, maybe a receipt on their end too. We'll pick the receipts, compare them, and say that these two transactions were successful. But the problem with that is the fact that it can be manipulated, right? It can be manipulated, and even data consistency, is not something that is very, very common in the fintech space when it comes to confirming transactions and all whatnot. Yeah, so that's why everybody relies on one system called NIP. You get that kind of to facilitate transactions. But imagine that you don't have to rely on a system, on somebody, right? You can just have a system that proves by itself that that every data on it is valid, right? That makes more sense. Okay, so blockchain explorers, bring all that information to light. Everybody can see it. It's not the transaction is not only exposed to the sender and the recipient. Everybody can see it. Anybody can go there and confirm that the transaction was actually carried out. Second one is that blockchain explorers help with transaction tracing. Someone said earlier that I was talking very fast, so I'm trying to like slow down. So transaction tracing, you can trace a transaction from who sent it to every single address or wallet that transaction hits up until the final recipient, right? You can do all that whole transaction tracing, right? But I mentioned here that this is very like suitable for transactions with shorter path. So there are some transactions that have longer path, right? They move from one address to another address until you lose track of them, right? So you can always use if you want to interact with a smart contract, you can always check if you're interacting with the right address by checking a blockchain explorer, right? So you can also check the address of a recipient. If you're trying to send a token out to me, for example, now I can always send you my address or my ENS name, and you can put it on the blockchain explorer and it tells you, whether it's valid or not, whether it's consistent or not. So those are some of the things that a blockchain explorer can do. Okay. So as I speak about every of these things that blockchain explorers do and try to justify why we need them, imagine how to build every of these two. Right. So imagine them. Don't just think of them as features. I want to assume that everybody on the call here is an engineer, but even if you're not an engineer, imagine building every single one of these features out, right? So don't just think of them as add-ons to a website. Think of them as full-fledged features, that are being used by people across the world, right? Imagine how you build features like that, how complicated they are. Yeah. So also when building dApps, you can, or maintaining nodes, you can always corroborate your data, with blockchain explorers and check if everything is fine. So if you're building a dApp and you send out a transaction and you get a response that contains a transaction hash, the first thing every developer does is copy that transaction hash, go to the explorer that supports their network and check if it's valid or not. I mean, it's very, how will I put it? It's this user experience that is not there, but it's there, right? Like it's not something that you cautiously do or that you think about. It has become a second thought, right? So it's like someone asking you about stuff and you don't know it. What's the next thing you do? You Google it. It's the same experience where you get the transaction hash. Next thing you're doing is looking for Etherscan or Bitcoin.com or something. Paste it there. You want to check whether it's valid or not. So they become a source of truth, just like Google has become a source of information, to us. Yeah. So that whole thing is quite interesting. So let's talk about the brief history of blockchain explorers. Before 2010, they were blockchain explorers, right? But they were mostly command prompts, So I don't know how many people on this call like to use Linux, but I will not lie. Ever since my university days, I was never a fan of Linux, and I had classmates who loved Linux. They like to type code, type instructions on the command prompt, and all those things, just to do one thing. Whereas me, I feel that you could just click, 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 and get everything done. Right. So preferences. So it turned out that I enjoy more I enjoy better human computer interaction compared to some of my friends. So the people who contribute to the Bitcoin core, Ethereum core, these are people who, like, you don't have a choice but to interact with the command prompt at some point, because you have to run a node, you have to you know, run tests, do all of those things to ensure that whatever it is you're working on, is correct. Whatever it is you're working on, makes sense. Yeah. So these guys are like, hardcore, command prompt guys. They probably don't even have any windows anywhere, giving them any fancy stuff, just typing stuff away on command prompts, So in your case now, if you want to check that a transaction hash is valid on the Ethereum blockchain, what you need to do is just you open a command prompt, type in a call to the gRPC, on your connected to so your command prompt must be connected to a node, a running node, right? So just type in the prompt, you see all these get transaction by hash, type it out, put the hash there, it will give you other detail, right? So imagine everybody in the world 2021 trying to do that stuff. It doesn't make sense, right? It's not usable, it's not enjoyable. Yeah, yeah. So it just doesn't make sense, right? So it's better if you can do this with by just typing it in a search bar, and a result is presented to you, presented as spitting it in your face. If you know what it means, fine. If you don't know, that's a personal problem. Whereas if you interact with, we'll look at examples later. If you interact with Etherscan, they labeled all the transactions. They made it so easy, right? If you check my tweets from like some 2 years ago, I've been tweeting about Etherscan and how awesome they are. You get that? Because some of these things I do them myself, and I know how stressful they are. Now to have someone doing it for you without having to think about it, it's a lot of work, and it's worth talking about. That's how I hear today. So um July 2010, there was some dude called Demos, right? His name is oops. Oh, how do I every time I click, it just goes forward. Oh, works now. Okay. Yeah. So July 2010. This person is a. You can check. These are links to some of their profile, right? I think they are anonymous, just like most Bitcoin core people. Some of them give quality that's published, and all whatnot. So you build something like that back in 2010. That was a lot of work back then. That's 11 years ago. That's a lot of work. Imagine back then there wasn't React, there wasn't Axios. Back then, what you had was Ajax. You had Ajax to make your calls. I had PHP. I had all those things. Yeah. So um, that was back in 2010. Then in November 2010 too, the same person published the first blockchain explorer, and they published it on this particular URL. It's no longer active now, right? But this is like a very a very cool thing to know, about things that happened in the past. So and then after 2010, or from 2010 onwards, you started having a boom of blockchain explorers. The Bitcoin.com, blockchain.com, all of those ones. Etherscan came in 2015. So many of them, blockchain explorers are like very, very, they go way back. They go just as far back as the Bitcoin nodes itself, having them on in public and all whatnot. So yeah, before we started having explorers, programmers used to use command prompts to interact with as their explorers, to check the validity of information, to check transactions, etc. So they use command prompts. And then some person on the Bitcoin forum developed like the first blockchain explorer, Bitcoin explorer. They call them demos. So the links to some of their profile is here. So I think they're on Twitter too and Reddit, of course. And then after 2010, we had a boom of blockchain explorers, blockchain.com, Etherscan, etc. So I'll just go ahead now and talk about the architecture of an arbitrary. So we pick any random blockchain explorer. What are the things we expect to find, right? So first and foremost, this is a conversation about software architecture in general, and then software architecture for um, a piece of software that interacts with blockchain, right? So most blockchain explorers, they intermix a host of a host of so there's someone here, let me admit them. So they intermix a host of um, software architecture patterns, right? Some of them include, as I highlighted here, layered architecture, event-driven architecture, microservices architecture. So these are like software architecture patterns that, if you are familiar with them, if you understand them, by the time I show you the next architecture diagram, you'll see, some of those patterns in the architecture diagram. Okay, so they don't use just one architecture. It's an intermix of architecture. So you have to use different architectures. For example, when listening for smart contract events on a node, for example, that's an event-driven, architecture, right? You are waiting for an event, so you have event processors waiting for an event to be emitted, and then when the events are emitted, they pick them up, they process the events, and then the data is being stored and manipulated and all of that stuff. So some of the components that you may find in a blockchain explorer includes a web interface. That goes without saying. So you need a web interface. You need tagging to tag transactions, to tag blocks, etc. Okay, so there's someone again. Okay. So you need a clustering engine to cluster results. So for example, you want to cluster transactions that are targeted to a particular contract, right? Or targeted at a particular contract. So for example, let's take Uniswap V2, for example. Let's pick Uniswap V2 maybe for swapping ETH and USDC. So there is a router for that. There's a contract for that, and that contract receives transactions, 24 hours, right? So since we know the contract address, we can cluster transactions, that are targeted at that particular contract, right? So that we can display them to users whenever they click on, or whenever they search for that contract address. We can show them a list of transactions that have been targeted at that particular contract address. That is why clustering is important, and the different algorithms for clustering, right? So this is like blockchain experts are very interesting. I'll call them a beast because it's a very interesting, highly scalable stuff to work on. Right? You need to be top tier, to work on this stuff. So you need workers or brokers. You need event processors, as I mentioned earlier on. So these are some of the things that you need in the blockchain explorer. So I'll show you this architecture diagram now. Hold your breath. Don't panic. I'll walk us through the diagram. If you have questions, ask questions. This is an opportunity to get familiar with seeing, huge architecture diagrams. They are just, squares and all whatnot. They're not that complicated. So, okay. All right, great. Yeah, so I hope this is not overwhelming to anybody. All right, so this is from one of the resources I use. So this is one of the architecture. So I'll explain some of the things that are happening here, right? And then I'll also highlight some of the architectures that are being used here. Okay, so let's talk about this first part of the whole thing. Like I told you guys earlier on, there'll be a web interface. So this is the web interface, right? So you are the user. This is a front end. They call it Angular, but it could be React. Does anybody use Angular anymore? I don't know. So it could be React, it could be Vue, it could be Svelte, and then there is a REST API that you interact with, and then there is an Express Node.js application running, right? And then there is there's also a web server behind. But let's talk about this first. So this architecture is a layered architecture, and it is layered because the request goes from layer to layer. If you notice, there's an HTTP request that comes into the front end. The front end receives the request, passes it to the routes, that's the Node.js. The Node.js receives the request and then reroutes the request to a server, right, on the back end as well. Okay, so you can see that this is layered. So this whole section like this is using a layered architecture, right? And also, occasionally, not all the requests might need to go to the Express Node.js. Some of the requests might need to go just go to the a data visualization tool. So just ignore the names. Right? Just imagine them to be technology agnostic tools that we have here. So some of them, some of the requests will just go directly to a data visualization tool, right? And mind you that even if the data visualization tool might have a caching system in front of it, right? So that itself makes it layered as well because it goes from layer to layer. So this is one layer, then this is the next layer, this is the next layer, and then this layer, that is the data visualization tool layer, returns data to the front-end layer before the front-end layer returns, response back to the user. So because it goes layer by layer, we refer to it as a layered architecture. So it exists in almost every application today. You cannot do without it. Okay, you can only enhance it. You can't do without it. Okay. Well, of course, you can do without it depending on your application. But if you're building a user-facing application like this, you most likely need a layered architecture. Okay. So so that's the web architecture side of this whole thing. Let's talk about these two parts of this. These two parts something I've done before, right? So now, oh no, okay. So now, point of note: if anybody knows Infura, Alchemy, those guys operate on this layer. This is what they do, right? They run nodes, right? And they provide node services to us. So imagine this entire layer, and then someone has built a business, on this particular small layer here, right? So just imagine that. So someone has built it. This is where Infura exists. Infura, QuickNode, Alchemy. This is where they all exist, right? So essentially, what you're doing is that you're running a Bitcoin node or an Ethereum node, and then you are running a client, right? Bitcoin CLI or Git client, right? That is interacting with these nodes. You can see the interaction between the client and the Bitcoin node, right? So there's Bitcoin CLI here, there's a Git CLI here, interacting with this, and then there are RPC calls, right? That have been sent to your monitoring agents. Right? So your monitoring agent is just, regular code, right? Web3 code, okay? Web3 code or some other, clients that can interact with, your Bitcoin clients. So it could Web3, it could be any other one, right? So these are collectors here, node collectors. So these node collectors are like, consider them to be listeners, right? They're just services that are running. You could refer to them as WebSockets, right? Waiting for requests to be sent to them. Okay, from these CLIs. So they're sending RPC requests to them. So you can refer to them as collectors. That's a more functional name to tell you what RPC request, what do they pass the request to a classifier, right? That classifier will classify all those requests as this is a block request, this is a newly mined transaction, this is a newly mined block, this is a smart contract event, this is a, like it's just classify them, right? So every block, every data collected here will be classified. If you see here, the collectors have already been specified. There is a network collector, there is a block collector, there is a transaction collector, there is a node collector to collect information about the nodes, there is a contract collector to collect information about smart contracts, right? So these are different collectors that are running behind. These are jobs that are always running. They could be jobs, they could be a server or a service just constantly running, okay? So, and then they are classified uh, this component here sends RPC requests to this guy. So it's mostly always events, right? Okay, so that's how this works. This is just a server running on its own. So you can consider this to be a monolith. This is just a monolith. A software is just running. It's just one software running. There is no there are other things going on internally, but it's just a single software running. So this is just a monolith, a Bitcoin node monolith, just running. Okay, and then your CLI is interacting with them. So this is client server architecture right now. So this is a client, this is a Bitcoin client, this is a Git client, this is the server. Your Bitcoin node is a server. So this is a client server architecture. The client interacting with the server and then sending information to the collector, emitting events to the collector, or even it could just be sending RPC requests, to the collector, to the collectors. Yeah. So, like I said, different architectures are being used here. Architectures are being used here. So now, next thing is pre-processing. So now that you've classified the data, what do you want to do? You want to process it, right? So you need a processing engine. Now, for you to use a processing engine, you can use something very simplistic, right? Write one script that processes data, and then what you do is just uh, after processing, just maybe store it somewhere. But that's very naive, right? You need something that is very scalable because you are interacting with several nodes, so you need something scalable. So this is also an event-driven architecture, but this architecture has a different topology, right? So this is called a broker topology, right? So a broker topology has two separate parts. There is a broker part, right? So these are the brokers. So brokers are like workers, right? So they are workers. Don't be too phased by the name. So they are like workers. So imagine stockbrokers in a stock exchange firm. What every single one of them is a broker, and they are working there processing exchanges, or processing stock transactions. So it's the same thing here. So the brokers here are just simply processing, classified data, right? So every single one of them is processing. So this is done so that you don't overwhelm one processor. So you have like multiple brokers, right? All of them working in parallel, right? So this is also taking advantage of parallel processing, right? So this is a distributed parallel processing. So now you need a processor after each of the broker picks up a request, you need a processor that will process the data, right? So you pass it on to a tool like Apache Storm. There are also tools that you can use. You don't necessarily have to use Apache Storm, and you can also build your own, processor, right? Event processor that work with the broker, right? So just that they have to work at the same what's it called, at the same um, skill level, and also that it must also take advantage of parallel processing. So this is like a very very important thing, right? So this a lot of things are going on here. There's parallel processing. There is as I mentioned here, stream processing. Between a broker and an event processor, right? So um, yeah, so this is what's happening here. So let me go over it again. Here, blockchain data is being emitted, sent to the monitoring agents. Here they are collectors. The collectors collect data, they classify it, and then they send the data to a pre-processing engine that processes the data, and then um, streams the results, to an event processor that processes events. After processing all the events, what happens next? You store the data in the database management system. So this is where the database comes in, right? So sorry, I'm catching my breath. Okay. So this is a database management system. This is a database. Like everybody knows what database is. So these are block database, transaction database, network database, node database, contract database. Now, mind you, this is very like simple. Some scripts attached to all the tables, all the database, working in the background, processing data, etc. And then you have a database management system managing them, distributing data across them and all whatnot. Okay. So above all of this is the analysis engine, right? An analytic engine analyzes data, right? That does the things I talked about, the clustering I talked about the other time, right? So clustering, like I said, is you have events, you have transactions targeted at one even your own address. So for example, you are a trader, right, and you receive transactions to your address every now and then. You post that transaction in an explorer, and it gives you a list of all your transactions. How did you think you came about that? By consistently running get transaction? No, it has been clustered. All the transactions they've been clustered, in the database to serve you. So that's all this analytic engine is doing, right? So you can see that there's a clustering analyzer that has different clustering algorithms. There's the K-means algorithm. I don't know what the algorithm is, but we'll know it. Subgraph or the graph. This is what they're providing to everyone right now, right? Where Etherscan is providing this clustering API, right? And then chainalysis providing something like this. Some of them are providing everything. You know, anomaly data API. So you want to check if there's a bad a bad actor executed through this. Then you also have to be processed. You have fine analysis and analyzing all the raw data and all. So you can see that there's a lot of things going on here. Data, a web server here. Just just put in transaction hash and you get data. It's more complicated, and it is just as complicated as every single one of these of these components. How they that you think about failures. If there's going to be failure, how do situations like backups, how do you handle redundancy, can Etherscan be done? The entire Ethereum community, right? Other exchanges as well. So this is just a summary of what you get when you're interacting with a blockchain explorer. These are the things that go on underneath. Most times, what we do here is just interact with these APIs, right? And then, in fact, most times, maybe what we do is just interact with this, right? Because all these guys are like background jobs, so they've done a lot of work in the background, and then they give you data here, right? But imagine situations where Etherscan is providing you data in real time. Right? It's a lot more, complicated than that. So these are some of the things that you do, for a blockchain explorer. And we've also not talked about, okay, it's an analysis engine, but contract analyzers, right? So you're analyzing a contract, you're wondering how you see it in an example that will pick, you're wondering how a contract, transaction moves from one contract call to the next. That's just one of the things that happens here as well. Okay, so I want to believe this is no longer like intimidating to everybody now. Now that I've explained it, I'm sure if you see this anywhere, like I know what this is. Like, and if I ever in an interview, trying to work with Etherscan, just show them stuff like this, just like, look, this is something that I've built before. I'm sure they're ready to hire you. Yeah. So these are some of the things that happen there. So how to use an explorer as a toolset? Yeah. So if an explorer is a toolset, how do we use it, right? How do we use it to facilitate our work? So let's pick some of these examples. So if you see here, this is Etherscan. Sorry, the lightning. My screen is light mode. It's usually dark mode. I don't know if dark mode is going to help anyone. This is affecting my eyes right now. Let's see. I don't think this is okay for anyone. Let me turn it back off. Okay, yeah, good. Okay, so I'm just gonna give me a minute. Let my eye adjust to the brightness. All right, so I'm gonna increase the size of this just in case. Yeah, okay. So if you see here, this was some random transaction. It has nothing to do with me. Please don't pay this as a transaction that was sent by me. I don't have anything to do with it. So if you see here, you can see transaction hash, the status. Like look at the presentation of everything. Now, if you let me open web3.js. Okay. Okay, so this is web3.js. Let's do a get. Let's go and find a get transaction. Get transaction. Okay. So if you call get transaction, using Web3, like that is this one is even code based, like with JavaScript. This is what you're going to get. Just look at this. Compare this to this, right? How does it? Can you see the difference? Right. This is way more usable. Now imagine this. Compare this to what you have in the terminal. How terrible that is going to look in the terminal, right? So I said I love things that even if the only work is just formatting it, front-end engineers will tell you how difficult it is to, format stuff like this, to make it look presentable and all whatnot, right? So this is data going from, this account to this account. When I click on this account now, what do you have? You can see data, all transactions to this particular account. It's telling you that there are 505 transactions to the account. How did they figure that out? They've clustered the data already, right? They've clustered the data. This is beyond indexing. You have to cluster here, right? So cluster data already for every single address. So it comes back to you. You can see all the transactions here, and you can click on every single one of them. It's an immense amount of work. Now let's look at state changes, right? So there are state changes because it's directed with the contract. There are state changes, right? Before the balance of this what's it called, of these accounts, it had this amount of ETH. Then later it had this amount of ETH. This is another thing entirely now. This is beyond just gathering data, right? It goes to get the balance as well, right? Look at the difference. So look at how much information they're providing to you. At the end of it all, they're showing you the miner. They tell you this was mined by by this person, right? And this was the balance of the miner. So this is how much Ether mine has in their accounts, over 1,000 ETH. So multiply that by how much ETH is right now. That's I don't know how much, over $3 million. So that's how much they have in their balance right now. So I can see that they are balanced before, they are balanced after. So it's also monitoring state changes. Not only just minor changes, also changes. If there were comments, it also indicate comments. So there's a lot of transaction passing, going on as well. Right. So I'll close this example. Okay, great. So I'll pick another example again. This is a more interesting example. Now, if you look at this example, you can see here, this is an interaction with a Uniswap V2 contract, Uniswap V2 router, right? So look at the breakdown of the transaction, right? So it's telling you that it was initiated by this address, then it was initiated to this particular contract. It labeled the contract, tagging, as I mentioned the other time, it tagged the contract, right? After tagging the contract, it showed you that there was a transfer from this address to some token address and then back to this user V2 router. And then from this user V2 router, which is this address, back to this person. So what this tells us is that this person carried out a swap transaction. So they were swapping. What were they swapping? See what they see. You can see here. It said highlighted events of transaction. They call it transaction action. Even the naming is very, very good. Transaction action, what the person did, right? And what they did was they said they swapped. Look, if I do this, if you do this via using Web3.js, you won't get any meaningful information. So they said they swapped, this amount of this token called quick. They added the token label, so which means they must have indexed, they must have a CDN that provides them information, that gives them information on this stuff, images. Okay, so they tell you that this person is swapping this token called quick for this amount of ether, and on what platform? Uniswap V2 platform. Can you see now? So this is very, 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 very detailed. Very, very detailed. These are recent. Now let's go and check internal transactions. So these are like contract calls that happen internally, right? This does not lead to like they didn't lead to actual how will I put it? They were not triggered by by an address. They were triggered by other contracts, which could also be an address. But I'm just trying to say that the calls were initiated within the contract. Okay. So these are like internal transactions that were happening. Okay. And then you have logs. So these logs are telling you, of course, logs, you can always get logs from, logs from the log RPC call for Ethereum. But if you notice here, you can see um, all the events that were emitted, right? You can listen for these events and see how each of them, is properly interpreted. You can see here how much being interpreted. You can see the final contract call called swap, the amount that was the amount of tokens that was swapped, and the amounts that they're going to get in ETH, right? Let's go to state changes. You can see state changes here. You can see that this is the person that initiated the transaction. Look at their balance before. Look at their balance after. You can see the difference. Obviously, they paid transaction fees, so they lost some ETH. Okay, and then look at this. The pool that held that the quick token. They didn't indicate. I'm sure they're still working on this. But if you look at the wrapped ETH token that they got in exchange for the token, you can see how the balance changed, right? And how much was lost in the balance. Okay, and then you can see that the final contract that was directed with using V2. You can see the miner as well. So this is a Beeple miner, all of them very rich miners. Okay, so like look at all this information. If I'm going to build something like this, imagine the amount of work you have to do. Now imagine how much they've done over the last 5 years, right? So it's really crazy. In this case, there are no comments, right? So, and also another thing you can do is you can so if you have a contract and you want to interact with your contract, you can interact with contract in 3 ways. First, you can interact with contract by a CLI. So you can use a tool like Hardhat, Hardhat CLI to interact with your contract, right? Alternatively, you can use Web3 to interact with the contract. The third option, which these days is becoming the more preferred option, is interacting with your contract via Etherscan. Right, so I published a contract just some minutes ago to give us an example. I would have published it again, but to save us time, let me just copy the contract out. So I published this contract on Matic Mumbai. No, sorry. Okay, so this is the contract. This contract simply just allows you to append value to a list, right? It's a very simple contract. But my point here is this: you can easily interact with your contract via Etherscan. Like this feature alone, imagine the amount of work it takes to building this feature alone, right? So building a DApp into an explorer. So an explorer has gone beyond just providing with information. There's now a DApp. There's analysis. There's events. There's all those things. There's all that stuff that they provide everything to you. There's code. They allow you to verify. You can see that my transaction is verified, right? So you can using it as an API. You can verify the transaction. It is when you verify that you can now do all this write contract, read contract, etc. Right? So you can see that I made an append call an hour ago thereabout. So, but just look at the work, look at the contract source code, the analysis they've done for it, look at the APIs, this one was extracted from the blockchain itself. Look at the APIs, look at the creation code, all those things, etc. Like that. So, you can do this as well to interact with your the last thing I mentioned, verifying a contract and then interacting with it via Etherscan is also one of the things that you can do, with an explorer. So look at all the things I've mentioned, all the features I've talked about, how interesting and complicated, they are. So this is a beast. A beast is a system that is, has many parts. You have to handle many things. Think of scalability, etc., etc. So this is very blockchain explorers are very interesting, very, very interesting. Okay, so finally, one of the things I also want to talk about is what are the things you consider when you want to integrate a layer 2 protocol? So these days you have Mumbai or Polygon scan, which is Etherscan for Polygon. You have Arbitrum scan, Optimism scan, which is Arbitrum for Etherscan for Arbitrum. So these guys, they work with Etherscan, to create to establish to have a what's it called for them, to have an explorer for their platform, a uniform and unified explorer, because of the amount of work Etherscan has done. They're able to do that. And for you to do that, what that simply means, there are like two things that at least I know for now. I'm still investigating this, trying to learn about it and all whatnot. First and foremost, you have to have a customized, it's supposed to be customized Ethereum clients that supports all Ethereum JSON RPC APIs, right? So yeah, in the case of Optimism now, Optimism created a customized client called um, uh, Optimism Geth. Okay, so that's what they call it. Yeah. So they had a name for it. The consensus mechanism on Optimism is different from that of Ethereum. Optimism is using optimistic rollups. Okay, so but the thing is, because they support all JSON RPC APIs. Etherscan could easily integrate with it because Etherscan essentially just calls APIs at the bottom of the whole thing. They will run if you follow the architecture we used before. Let's look at it. So here, instead of Ethereum or Bitcoin now, what you're doing is you are running a node, but you are running an Optimism node. You understand? Optimism node. That Optimism node is very similar to the Ethereum node in the sense that it provides the same APIs as the Ethereum node, but internally it has other things that were customized. And then you have a client that will connect to the Optimism node, and then it goes back to all of this whole thing that happened here. Now you can see that if you've correctly designed your architecture around here, in fact, integrating with any new layer 2 protocol that supports all the Ethereum JSON RPC API is very, very easy, because now you don't need to do any of these anymore. You don't need to do any of these to start to work. The only thing I need to do now is have new additions to analytics engine, because Uniswap, for example, on Etherscan is not the same as Uniswap on Optimism. So you have to do clustering for that. But that is just as simple as setting up a clustering server, analyzer for it, right? So that's an example of something to do. Another thing again is to ensure that your node is hosted on this provider. So have your nodes on Infura, have a so that Etherscan can connect to those nodes. Of course, Etherscan can run its own nodes as well too. You get, but essentially this is the these are some of the things that you should consider. Okay. So in summary, I mean, blockchain explorers have made it easy for anyone to understand blockchain data, by making highly technical information about blockchain easily searchable and human readable. This technology is, however, not trivial. It's a beast that has been tamed by many years of research and existing to. Why did I put every time here? I have no idea. That must have been a mistake, but yeah, you get the point. So that is the summary of this conversation. So I think that's the end of this. Okay, these are my references. I read some articles for this. So that's the end of this conversation. I hope I've been able to give you guys like a very good technical primer on blockchain.